Hi everyone, and welcome to episode 2 in our AI EQS series. In this episode we are going to add a behaviour to our AI to run away from the player and choose a hiding spot. So if I push play, for example, this is what we're going to be achieving, is the AI running away and finding a hiding spot from the player. So it evaluates the location, searches for a hiding spot which is simultaneously as far away from the player as possible, as well as close as possible to itself as well. So that's what we're doing, and we're going to get started right now. Okay, so to get started, we have what we had from last time, in the last episode, which is the AI using EQS can see where the player is, and when the player hides, the EQS says, well, it returns false. Okay, so the EQS won't do anything unless it sees the player, which it has here. Okay, so we can hide and he can be seen. Okay, so when it goes green and it can be seen on the behavior tree, the sequence will now run to the next node, which is going to be another EQS query, which will allow our AI to run away and hide from the player. So if this returns false, i.e. can't see the player, the sequence won't run and it'll go back up the tree. Okay, so that's why we have that. So let's do the EQS for running away from the player. So we've got the find player one. We need to make another one. Go add new artificial intelligence, environment query. I'm going to call it hide from player. Now, part of this is going to require a new, what we call, context. Now, if I go back to our find player, you can see that we use the word context quite a few times. So if I click on my trace to, and down here I've got trace to context here, environment query context querier. So context is basically where either a location from or to that you are looking at. Okay, so this location is usually the location of an actor or a series of actors. So by default there is a context for the querier, so the thing that is running the EQS system, in this case the AI, that's already in there for us. However, we want one as well for the player, because we're going to be needing to know where the player is so we can hide away from him. So let's create a new context. So to do that, we're going to go add new blueprint class, and in your search box you want to type in the word context, and you'll see environment query context underscore blueprint base, and I'm going to call this context player and open it up. Now a context is just a blueprint, but it will be outputting an actor or series of actors. To do that, we have to go over to where we have our functions list here, and we want to override. Click on override and you can see a series of functions that we can override, and we got, more importantly, providing a single actor or providing an actors set. For this I'm going to do an actors set. So if I have multiple players, for example, this will work regardless, okay, because it returns an array. So from here, I'm very easy one is I'm going to get all actors of class, and the class we need is whatever the player is playing as. So we go third person character, and this outputs an out actor, and that's it. Compile. We've now got a context. We've got a list of actors that we would need for our EQS. We can close this context, and I'm going to close the find player one. We don't need that. And now we're going to do the hide player. To begin, we need to generate first of all a series of points or nodes or locations that we need to be able to query. So to do that, we need to drag off here and generate something here. And I want to generate a grid. So go points grid. And this will generate a grid of points around the querier. Okay. Now we've got some settings over the side here where we can change the size of the grid and how much space is in between each of them. So if I just pull this to one side and get around in our world to see our EQS testing pawn, if I have it. Yep, so here's my EQS test dummy. I want this guy to use this one I'm making now. So if I with him selected, scroll down and see query template and just drag in my hide from player, you can see now the grid that it's generating. Okay, they're a bit too close for my liking, so let's try 150. That's a bit better, and let's make them a bit larger as well. 1000. Okay, so it's going to search in 1000 radius around, or grid of 1000 radius around the AI. Okay, now I want it to generate around the querier. You can make it generate around anything. So if I wanted to, I can click on this and generate around the player context. However, I don't have a player context already in there, so let's just put a player context in there. Sorry, a player in there, and this should generate around. I'm going to click save, and there you go. With it saved, you can see how it's generating a grid now around our player context because it's a player actor in there now. Now, I want that AI to run away from the player, so it's kind of pointless searching for a location near the player or around the player. So let's change that back to the querier. Okay, and I can remove that player from there. So with my context selected, I can see the grid. Now, a few things we're going to change first before we carry on, and that's how it's generating it. So at the moment, it's just plonking them to the floor. So we can raise this up a little bit. So if we can go over to here, we can see, where is it? This post projection vertical offset. There we go. So this value changes how off the floor it is. Okay, so if I were to do say 50, you can see it rise up above the floor, and you want to put it at a value where the player or the AI wants to be looking for, because it's always running tests towards these items. So you want to put them in a location which makes sense. So I usually aim for like middle of the body, so 50 or 60 will be just fine. Okay, you can see here that's around the waist of the AI height. Okay, the next thing we need to do is tell it how it's projecting it. So the way it projects it is that it kind of projects up and down to decide where one of these items go, and we can change how it projects down and up here. So if I were to change, say, project down here, I think it's this one, let's have a look, to 2048. Nope, not that one. Let's try this one, 2048. There you go. So project up, it will move nodes that were underneath or clipping through floors up above any geometry. So up on these stairs, for example. Okay. And that's kind of what you want it to be like. Okay. So you can tweak these numbers based on your level and the geometry that you've got, but this will work as is. Click save. You want to save regularly because it is still experimental, so you want to make sure it don't crash on you. So now we're going to add some tests to this one. So the first thing we're going to do is check for visibility. Okay, so I want to actually let's do visibility. So go add test, and we'll do trace, and the trace you got here. You've got trace to querier on visibility by default. I don't want to do it. I want to do a trace towards the player. Okay, so I want to exclude everything that the player can't see. So trace to, change the context here to the context player. You see it all change here. And I want to change my test purpose at the top here from filter and score to just filter. Because I don't need to score them, I just need to get rid of the ones that return true when they are being met by the player. And let's just drag the player out into the world so you can see how this is going to work. Buckets, and why is that not working? Click save. There we go. Click and save. You can see here the ones that have been filtered are blue. Okay, so the blue ones can all see the player. The red ones though can't. Okay, So the ones above here, the player can't see. So this is where you can mess about the offset a little bit, because the offset will determine quite a lot. So if I go back to my grid here and change this to 120, you can see how putting that height of the head changes the visibility of some of these items. Okay. So now we've got our filtered bits, we've got the bits we want, which are the red ones, and you can see they've got a score of 0. Now the way it works is the AI is going to choose the one with the best score. So at the moment they're all scoring 0 because we've only just filtered them, we haven't assigned any score to them. So now we need to decide which one is going to be the best place for the AI to run to hide from the player. So to do that, we're going to add a couple of tests into this. So I'm going to add another test and call distance. Click on distance. And we want to change this distance to player context. So in the distance 2, change to context player. And the test purpose, we want the score only. And you can see how it's scoring these nodes. So at the moment it's distance 2, context player, and it's scoring the one furthest away from the player with the highest score of 1. The one closest to the player, this one here, has a score of 0.34. So it won't pick this one, it'll pick this one. Yeah. So it'll choose the furthest one away. However, we don't want to just make it go choose the one that's furthest away, because otherwise it'll just run to the corner over here and not be realistically hiding away. You want it to be hiding behind boxes and corners, things like that. So we need to change this as well, so not just run away to the furthest point away from the player, but also the one that is closest to the AI. You don't want him to run away too far. So we're going to add another distance 2 on here as well. So add test distance, and this one's going to be distance to querier. Again, score only. And at the moment you can see it's doubling up. So because this one is still the furthest one away from the AI and the player, it's still 2. However, this one I want to get the closest to. So on the right here, you'll see scoring equation is linear. You can change this to inverse linear, meaning it will score the ones closest with the higher marks. And now you can see that the items closest to the AI are now scoring higher. So now it will choose this point rather than this point as its hiding spot, because it is close to where it currently is, but yet can't see the player and is still relatively far away from the player, okay, compared to say this one. Okay, so currently that's the best place for it. Now we can keep adding tests if we like. We can add another one. Click save, add test, and we can do, say, a pathfinding one. So a pathfinding will make sure that we've actually got a path to these nodes. There's no point, because some of these points may be in a place where it can't get to, such as this block here. We don't want it to pick these ones. Okay, so if a path exists, we want to just filter out if no path exists. So path exists, test mode, context to the querier, which is what we want. So remember, you're going from item to the querier. So if there's no path from this item to the querier, it will just filter it out. And click save. And that way it'll filter out anything we can't get to. It's not the case in this one because it's all filtered out anyway, but it just saves any issues further down the road. What else we can do is we can also do a dot. If I go right click here, add test and do dot. A dot query test. What that does, it tests how alike 2 rotations are. So the dot query rotation from line A, the first rotation, we want to test the player context, and we don't filter on score, we just want score only, and we want to change the line, line from querier and line 2 to context player. Okay. So now you can see it's still going to favour these ones here. Looks like 2, 5, 2, yeah, 2, 1. Okay. And what this basically does, it means this allows you to, in this case, what we're going to do is make it so it chooses a point which is not directly in front or behind the player's rotation. So it's going to pick either side of it. So here on the scoring equation, the scoring factor here is 1. If I change this linear 1 to a -1, it should equate out those that are facing the same rotation as the player. So if I just rotate the player a little bit, let's see what that does. Not much. Okay. We don't need to do dot, I don't think, in this case. And so with the dot test, with this, the absolute value needs to be -1, -1 ticked as well, and it basically checks whether this whole dot tests whether or not how two alike two rotations are. So if they're exactly alike, it'll be a 1. If they're completely not, it'll be -1. Okay, and we want the ones that are not alike, so it'll choose items which aren't in front of or behind the player. Okay, so this -1 forces it to choose to left and right. Dot's quite confusing. You don't need to use it, but it's useful. And that's kind of it, I think we can do. What else we can do? We can make it so it only chooses items that the AI can't see as well. So we've got a trace here to the player visibility. We can also do another trace if you like. So let's add another trace. And the trace here is going to be filter only. And the trace is going to go from the AI context, so normal query, and we want to filter out anything that it can see. So it always look for ones that it can't see. So all these ones back here which it can't see, it will choose these and favour these ones. Okay, it can see these, so it's not going to bother with those. It's always going to look for somewhere it doesn't see and that the player can't see. So hopefully this all makes sense. You can keep adding tests as much as you like. The order doesn't matter too much, especially when it comes to traces. Traces happen no matter what, wherever they happen first. So click save, and we're done with this, I believe. Okay. Next we need to do is go back to our behavior tree and run an EQS query, and we need to choose the query template of hide from player, and the resulting Blackboard key we want to be the predator, which would be this actor here. Okay. Okie dokie. Yeah. So going blind. So on your behavior tree, we want to drag out and add a run EQS query. You want to choose your hide from player query, and the Blackboard key we want to be this target location key, a vector key. So add new key if you haven't already got one, and make it a vector location key. And on your run EQS query, the second one you have, you want to change the Blackboard key here to target location. So after that, we can now do a move to, and want to move to target location, which it should be by default, but if not, make sure it's changed to match that key. So let's run through what's happening here. We first of all test whether or not we can actually see the player. If we can, we're going to start doing this. If we can't, it will fail out and just keep checking. And now we're going to hide from the player. It's going to find a point which is AI can't see, the player can't see. that is as far away from the player but as closest to the AI as possible, and it's preferring ones to the side of it. So I'm going to click save and then finally move to. Okay, so let's test this out. If I delete my template one there, I've got my AI here. Hopefully AI will run away from me, which he has done. But if I sneak around the corner, bosh, he'll run away. Okay. There you go. And he'll keep running away from me. There you go. And that's basically it. So, really cool, powerful way of using EQS to have AI, oh yeah, jump on him. Boo! Ah, I gotcha. Run away from you as the player. Where are you going to go now? That's right. So, super fun. You can do really cool stuff with this. And it's the start of how you make AI find cover. Because you obviously don't want to run away all the time. You want it to like retreat and then find cover or find ammo or find allies and then go on the attack again. So next time, what we're going to do is we're going to make it alternate between attacking and defend and running away. Okay. And that's it. If you have any questions about EQS or AI in general, please leave a comment below. If you have any suggestions about what AI you would like to see, that would be great. Leave it below as well. Thanks very much for watching, and I'll see you guys next time. Bye bye. Big shout out, thank you to all my patrons. Wouldn't be doing this without you guys, and a big special thanks out for Alex and Jacob for donating $20 a month to me. Thank you very much. That means the world. I can't believe you guys are so generous. It really means the world that you guys are helping me out do this this little venture. And yeah, thank you very much to all other my patrons for donating. If you want to be a patron as well and get access to videos such as this, head over to patreon.com/Ryan Laley, and you can donate up to from as little as $1. And you can join our Discord, see all the videos nice and early, as well as exclusive ones, behind the scenes stuff, all sorts of goodies. Thanks very much for watching, and I'll see you guys next time. Bye bye.